So now let's talk about Chapter 5. Here's an abbreviated list of the major topics within Chapter 5 that you'll need to know for the exam. Beginning with ions. Ions is an element that has a charge. Can be positive or negative. Remember, your positive type ions are called your cations, and your negative are your anions. The cations are metals, and your anions are nonmetals. These are usually on the periodic table. They're going to be on your left side. Also within the transition elements, some of those will have more than one positive charge, and some will have one positive charge, and those are all cations as well. Again, the anions are going to be your nonmetal portion, which brings us to bonding. Ionic bonding is going to be bonding between two ions. The first one is always going to be your metal or your cation. The second one will be the anion or your nonmetal. Do be familiar with the general naming conventions for the ionic bonds. Know how to write the formulas. Go name to formula and formula to name. You can refer to page 177. There's a really nice color-coded periodic table listing the charges of the various ions throughout the periodic table. The next topic is going to be polyatomic ions, poly meaning more than one. There's a list of 20 of those on table 5.7 on page 180, so do be familiar with the polyatomic ions and also know how to name those when they are going to be making ionic bonds as well. Also know the Roman numeral convention. If you have a transition element that does have more than one charge state, such as iron, be able to know the difference of how to specify if it's an iron 2 or an iron 3, for example. Covalent bonding is going to be between two nonmetals. These will be on your right side of the periodic table to the right of that metalloid portion that we talked about earlier. Know how to draw the different electron dot structures that you'll use for covalent bonds. Know how to name them, right, again, just like you did for the ionic type bonds. Know how to go from formula to name and name to formula. Types of covalent bonds that are diatomic, naturally diatomic, meaning that they exist as a pair bound together in their natural state. There's 7 of those. They're listed on page 184. I like to list them in this order with the mnemonic to remember them: Brinkelhoff for bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. So do know and be able to list out the 7 naturally diatomic molecules. The next part of the chapter is going to be electronegativity, the tendency of electrons to shift towards a specific atom in a bond. If you have an equal electronegativity difference, for example in any of the diatomic molecules, it will be nonpolar, also know polarity, meaning that there's not going to be a pull towards either one. It'll be an equal pole on each side, kind of represented how I'm showing with my hands here. Whereas if you had something, for example, like hydrochloric acid, which is HCl, chlorine is more electronegative than the hydrogen. There would be a general more of a pull towards that chlorine, and so you would have what's called a dipole going towards the chlorine portion of the molecule. Be able to know the nonpolar versus polar and dipoles, and also be familiar with the electronegativity differences within the atoms. The most electronegative atom, be familiar with this, is fluorine. Fluorine has an electronegativity value of 4.0, and then in relationship to fluorine, as you kind of look at the periodic table, as the elements are arranged and as they are closer to fluorine, they have a greater electronegativity. As you get further away from fluorine, there is a decrease in that electronegativity. Electronegativity will increase as you go across your period and will decrease as you go down each one of your groups in relationship to that fluorine. Again, those values are listed on page 193. Know the shapes of molecules. We had a lab that went through the shapes of the different molecules based on how you drew the electron dot structure, and that is derived from the number of valence electrons for each one of the molecules, and you count that up and you'll be able to draw that. There's a nice table giving examples, 5.16, which is on page 198. So I would take a look at that table and be familiar with the different shapes of the molecules. And then ending out this chapter is going to be your attractive forces in your compounds. Again, there's a nice table, page 201 this time. This is table 5.18, listing the attractive forces that you will find within the compounds. This is discussing both ionic type compounds and covalent type compounds. Starting with the highest energy, going down to the lowest, you're going to have your ionic bonds, your hydrogen bonds, your dipole-dipole interactions, and then the lowest type energy of these in relation to the other is going to be your dispersion forces. So go ahead and take a moment now if you would like to pause the video and write down these topics. Do that, and then we will come back with Chapter 6.